We've had this in play now for about 2 years, so this isn't anything new. We haven't really changed anything from when we started 2 years ago. We're just trying to reinforce it. We do have a lot of new contractors coming in. We have new framers come in the area all the time, so there's a lot of municipalities that aren't really enforcing. So it's right. As a builder, you should be building under the 2009 code. It is mandated by the city or by the state of Oklahoma. All areas of Oklahoma are required to build under the 2009 code. So it's not just something that's hey. Hi, Steve. Hey, how are you doing today? Got some donuts up there on the counter if you'd like one.
He's already got the coffee.
It's cold already. So anyway, we're working on this, have been, same thing going on, okay? This is the fifth class I've put on this. So. Sean Hudson's with sales representative with Simpson Strong Tie. I'm going to let him tell a little bit more about himself. He's going to be presenting the class today and has a lot of wisdom and knowledge, and I'm sure he's open to any phone calls and would help you with plan design, any type of brace wall that you need. With that, I'm going to turn it over to Steve. Thank you all again for coming.
Thank you, Bill. Appreciate it. Make it easier to see the. There we go. Like Bill said, I'm Sean Hudson. I'm with Simpson Strong Tie, territory manager, cover all of Oklahoma, central west Kansas, and then Panhandle of Texas, Lubbock and Robo area. So we've got a large territory, and we have quite a few people in the territory. We've got a dealer sales representative that calls mainly on lumber yards and on the supply side of it. I work more on the demand side of it with architects and engineers and things like that, and deal with a lot of the larger jobs, doing multifamily and things like that, working with general contractors there. But I've been with Simpson for a little over 11 years now, and I'm based out of Oklahoma City, which is where I live. Our branch office is in McKinney, Texas. It services the whole southeastern United States. Just to get a feel for everyone here is builder, except for one engineer. Kind of like to know who we're talking to, and include them in anything instead of talking about everything that may not pertain to them. So, like Bill said, we're going to discuss the 2009 IRC for brace wall provisions. I've cut out a lot of this presentation. It's only a 4-hour thing, but what I've cut out is kind of the history of it. So I'll break down the history of brace walls just without any slides. One of the first questions is, especially when a municipality starts enforcing brace walls, is why are we having to do this now? We've never had to do it before. It's never been in the code. And it's nothing that's new. It started off in 1927 with brace walls, and it was as simple as it was just 12 words in there. Every exterior wall shall be braced. That there was no, it's just vague. To where it evolved into using 4-foot sheets of OSB. There's still some intermittent methods in the code that are really outdated to have no wood board like they used to use. Things like that we won't go over. We're just going to touch on the main ones that we actually see today. But like I say, it's been in the code since 1927, and really since 2000 is where it's really started vamping up. And the reason I say vamping up is that the ICC is comprised of builders, engineers, and building officials. And they're the ones that actually make the code. So around 2000, 2003, and really 2006 is where the builders got a lot of input in it. There some kickback, some concerns, and some suggestions from the builders, to where in 2006 you had a couple of ways of doing it. And it was wall bracing, it was fairly simple. You didn't have to use a calculator like you do now, but it was one in which you had to have 25% of your wall, or 16% of your wall had to be braced within this region. So it was easy enough to do. You can say this wall here, take the length of it, I need 16% of that needs braced, and here's my options. Well, say the builders wanted more options, so they've come up with having to use a lot of reductions, or you get reductions if your eave to ridge height is a certain thing. So now you have to take into consideration your eave to ridge height and your wall height and different things, which we're going to go over. But like I say, that's evolved into what it is today. There's a lot of options, and it makes it not necessarily more complex, just more time consuming in the way of having to figure out how much bracing is needed. But there are calculators out there that make it easy. You don't have to sit there and go through the book and say, okay, my eave ridge height is this, what's my reduction? You don't have to go through a book, you just put it into a calculator and it does it for you. So it is pretty easy. If you guys have any questions during it, just shout out, raise your hand, whatever. Get a phone call, go ahead and take your phone call. We appreciate it. Step outside. I know it's you guys conducting business, so feel free to do that. And if you don't have any questions, I will get started. So the objectives for today is we're going to try to get you to understand the need for bracing and determine the most cost-effective solutions to meet that. We don't get up here and say, yes, I am Simpson Strong Tie, but I don't get up here and talk about our products unless actually noted in one of our pieces of literature. I'm just here to talk about the code. We're not the only manufacturer of products, so there are others out there, but just kind of the way I go about doing it is if I sit down with you guys and go over your plans, I'll suggest resizing a window, moving a door, or whatever. We don't just go through and say, yeah, you need a strong wall here, you need hold downs there. That defeats the purpose of it. The purpose of the code is to do it the most cost-effective way. So if that's one where I assist you, that's what I do, is go through and just try to really eliminate any of the hardware. So you want to do it in the most cost-effective manner. Okay, so wall bracing. The three parts of the wall bracing that you're trying to resist are these here: the racking, sliding, and overturning. So if the force is acting on your structure, it's going to start with doing these three things right here. So if you got a wall built, no framing on, no sheathing or anything, and you apply a force to it, what's the first thing that's going to want to do?
Right.
Yes, sir. You're going to put force on there. There's no, these are just all hinge points here without any sheathing on it. The four corners there are just a hinge. So you apply that force there, and Cecil's exactly right. It's going to want to rack. So what you do there, there's some examples of racking, even with sheathing on there. It's not completely built yet, but it does have sheathing. But you're going to get some racking there. So what you want to do to avoid the racking is by putting sheathing on there, nailing it to your bottom plates and your top plates, and that's going to help resist any racking. So if you've resisted the racking and you apply that same force, what's the next thing it's going to want to do if it's just stiff?
Lift.
It'll want to slide first. Well, it could. I mean, if there's enough pressures and everything's built, the roof's on it and everything, yes, it could definitely lift. But it's going to want to slide there, and so what you'll want to do there, you see some pictures of foundation or how home sliding, and of course this is brick here, block here that you can see aren't filled. They were just filled in sections where they had anchor bolts if they did on this one here. but in a lot of areas, you do see that, especially older ones, I mean, not so much nowadays, but, in the older homes, you'll see that, you know, they're supposed to be all grout filled cells in those blocks, but, they weren't always. This one here, you can see the house just blew off the foundation here, and, you kind of look at it and say, well, there's a tornado, there's nothing's gonna prevent that, from happening. But, a lot of the shrubs, I mean, you can still see flowers on shrubs and stuff, so it's not that it was a direct hit from a tornado, maybe outer lying. But what you can see is there's just some holes here, and then maybe just some shot pins or cut nails probably. Some municipalities, used to allow just cut nails. So if it's not positively attached to the foundation, that's what it's going to want to do. I mean, it's holding on for dear life, trying to stay to the foundation there, but it dragged all the way across there. So good positive anchorage into the foundation, which code requires half-inch diameter bolts, 7 inches embedment, 6 feet on the center. And there are alternatives to that. Some people will use products like these here in the essays, to where if you have an L bolt that's misplaced, or they don't know where walls are going to be studs or openings or or anything, so with an L bolt it may fall in line with a stud. So if it falls in line with a stud, what you're going to have to cut that bolt off and actually replace that. With these here, put these in during the pour. It's a product that one leg can go up a stud and the other can go over the seal plate, or they can both go over the seal plate. So you don't have to worry as much about misplaced L bolts when it comes to studs with a product like this here. And then we've got products. A lot of people have products that are post-installed products for misplaced L bolts, misplaced anchorage. If you have to have at a splice by code, you have to have an anchor embedded into the concrete within 12 inches of that splice. No more than 7 bolt diameters, and no less than 7 bolt diameters, no more than 12 inches from that splice. So in that case, I know a lot of people will end up using possibly wedge anchors for that application, but wedge anchors, no matter who the manufacturer is of wedge anchors, you can't use wedge anchors for sill plate applications because of edge distances. It's an expansion anchor. So when you're tightening it down, it's just putting forces on that concrete. So that close to the edge, if you were to torque it to the recommended torque, and recommended torque for half-inch wedge anchor is 60 foot-pounds. Well, no one knows what the torque's supposed to be, and no one has a torque wrench, so you may not be tightening enough, or you may tighten it too much and actually slip that sleeve off of there a little bit. So if it actually is engaged, it can just slip out of there very easily. So post-install non-expansion anchors are good for those applications, and products like, at least with ours, is bolt size is hole size. So if you have a half-inch bolt, it's a half-inch hole that you drill. And these, you don't have to have 7 inches of embedment. For ours, you use a 6-inch, so you're going 4.5 inches into the concrete. Probably drill out a 5-inch hole, so you don't have to blow the concrete out, or you can go 4.5 inches if you are going to blow the concrete out. All that does out. But it's, again, bolt size is hole size, non-expansion forces. It's like the little Titans, those little blue Tectons. It's just a larger version of that. So bolt size is hole size, it cuts into the concrete, and it's where you get your bolt.
How do you get away with just 4-inch embedment if code 7?
Because of testing. You can test out what a half-inch anchor bolt is, half-inch L bolt. You can do the testing on that and figure out what pull value is and what shear and everything is. And as long as
4-inch
you
embedment on that would have the same tension rating as a 7-inch.
Let me say this, the code does say 7 inches embedment, but we allow optional products as long as you can provide an SR report from the ICC evaluation committee, okay? So if they say they've tested this and it meets or exceeds the requirements of what's in the code, I will normally allow it, okay? And that's where we're getting to use some different products. So not only Simpsons, but there are several other companies out there that are making products As long as they meet the requirements of the ICC, I will allow them, okay?
Is there another?
It's
part
kind of
where you're
like,
allowing
we used to
other-
allow powder shots.
You do?
We used to.
Okay.
But the last evaluation that we had on powder shots, the ICC removed some of the requirements in there, and they no longer allow them unless they are designed by an engineer for placement. They won't tell you a minimum distance that you have to have them, so they've been disallowed at this time.
And that's the key thing you'll see in the code book is that whenever you talk about any subject, like say with anchorage, it tells you what it needs to be or approved equal. And the only ones that do the approved equal are the building officials in the municipality. They're the ones who will say, yes, we will allow this, or no, we won't. And usually that's based on ESR reports, which code evaluated reports. Those code evaluations tell you what the material is, what the product is, what the application is, what the material is, how they're to be installed, and all the substrates. I mean, it goes into detail every single thing about that product and gives you test results and that, yes, this is approved equal for this type thing. So
So Hilti nails are no longer, when did they go away?
January 1.
Oh,
We, I believe it was in October or September that they put out a new
engineer or ESR.
ESR, yeah. They put out a new one, and it disclaims that now, unless it's designed by an engineer. So I don't think anybody's going to want to spend that kind of money to have an engineer come out and draw a plot plan for where to put guilty shots. If you do, it's acceptable. It says in the code that it's allowable, so.
It's being by an engineer. So anyway, so you're going to want to positively anchor your structure to the foundation there. So once it is anchored we showed a couple of different anchors here, elbows, and then that's if you're going on to concrete foundation. But if you're on raised floor of some sort, then you're going to use anchor bolts into there, and then the tie plates here into a brickboard or something. What have you there for your raised floor. So once you're positive, you have your sheathing on, and you're positively anchored to the foundation, well, it's no longer going to rack, it's no longer going to slide. So now the next thing it's going to want to do is it's going to want to overturn. So it's going to want to try to pry apart from this bottom plate, because that bottom plate is attached firmly to the foundation there. So to avoid this, you can see this is a sample of overturning. And house was built, lived in and everything there. It just you're so tall and narrow there that the way I kind of analogy I use is a football player versus a basketball player. Tall, skinny basketball player, you can tip them over a lot easier than you can short, stout football player. The wider, the better. The more resistance to the forces you're going to have. So now what you'll want to do to prevent overturning is have some sort of hold down. It's going to positively attach to the foundation through the sill plate and into those outer panels. This is would be a shear wall panel, brace wall, shear wall panel now that you're using the hold downs. So that's going to keep that panel in place. One, it's not going to overturn or not going to rack because all your sheathing. It won't slide because you're anchored into the foundation, and now it won't overturn because you're resisting those forces on the edges there. Requirements of the 2009 IRC. Some of the terms of brace walls, just to kind of break it down into what exactly brace walls are and what they're comprised of. What they are comprised of are brace wall panels. Within one brace wall line, you have brace wall panels. And the height of the panel is obviously the height, and then the length, or sometimes they'll say the width is just that, how wide it is or how long it is, and not the height. Then you'll have brace wall. I should be brace wall panel spacing. Brace wall panel spacing requirements, and then your brace wall length is, from this whole wall here, is the length of that brace wall. And we go into the spacing of brace walls, the ends of brace walls, what's considered the end of the brace wall, where you can actually die it into another wall, or it has to extend to an exterior wall. And then you also have brace wall spacing, your brace wall line spacing. So you have maximum requirements, can't be over 60 feet between brace wall lines. And we go a little, lot more into detail on that. So brace wall lines, code states that all exterior walls have to be part of a brace wall line. So that's what you look for at first. Whenever I'm doing a brace wall line layout, and real quick on layouts, is that in 2009, the code, it got put into the code that building officials now have the authority to require brace wall, your permits, your plans to be marked up with your brace wall lines, how much bracing is required on those wall lines, and how you are getting that amount that is required. Where are you actually getting that? What method you're using? So some municipalities, and really that's the only way that you can really know that you're building it to code, because if they don't allow, or if they don't mandate that you mark up your plans, they're just out there looking at wall bracing. They don't know how much bracing is required on each panel or on each wall. So it's kind of a crapshoot thing. I know a lot of municipalities aren't requiring brace wall line layouts, but at least what they are doing is that if it is a brace wall panel, that at least the brace wall panels are built to code. You may not have enough bracing on that wall for the whole wall length there, but as long as you're calling something a brace wall panel, then it has to be built to code. So that's kind of what they're doing. But like I said, build is requiring plans to be marked up, and that's what we'll go over. I've got a set of plans here on how to mark up the plans there. But that's how I start off, is with every exterior wall, working on the exteriors first. You may have to pick up interior walls as well, but what I do is start off with the exterior walls. Your brace wall line is a space at a maximum of 60 foot on center, and then you have some seismic requirements that we don't fall under. So all we need to worry about is the 60 foot on center for your brace wall line. So every exterior wall, in the same direction, in the parallel direction, can't be more than 60 feet apart. And you have offset requirements as well, and you're allowed to have a 4 foot maximum offset from your brace wall line, and we go into detail on all of those there. But example of all exterior walls have to be part of the brace wall line. That's exactly how I do it. I kind of go through and make sure that all my exterior walls are accounted for, part of one brace wall line or another. Maximum of 60 foot on center, and this here is shown with an offset here. And I won't use this example to explain the offsets. We've got some more to show you there. But it's showing a maximum between this brace wall line and this brace wall line is 60 feet, and the same thing between B and C. That's a maximum of 60 feet. Designated location of brace wall line at building exterior, 60 feet. Note at the bottom is brace wall spacing from brace wall line B is the greater the distance between A and B or B and C. So it'll make more sense when we can put it into the calculator and what the calculator actually prints out. It'll show that if this is 60 feet and that's 35 feet, it's going to show distances of 60 feet on your brace wall panel. Because the bigger of the distance between A and B and C is going to govern how much bracing is required on brace wall line B. So it can't say that I've got 35 feet between B and C is going to require less bracing on B than it would be that if you had brace wall line A all the way over here and it was 60 feet apart. So that's how the code interprets that, is why they designate that the amount of bracing required on this wall line And this wall line here is got about that distance there.
Now, how is that stopping at the offset? I don't understand how that offset is.
Well, yeah,
It appears to me that that should be 64 feet.
yeah, well, I'll show you here now. We'll go over the offsets and angles and everything. So part 3 of that was 4-foot offset. Your brace wall panels and a wall line may be offset 4 foot maximum out of plane offset, or 8-foot maximum total out to out. So we can go through all these examples here. Say 2006, all you had was a 4-foot offset. You couldn't go any, like this one here, this would be, this is a brace wall line here, you went 4 feet, okay, that's as far as I could go, and then I can bring it back here. So in 2006, you can say this is a brace wall line to here. And then you had to say this is a brace wall line in the perpendicular direction, and this is another brace wall line, just because of the offsets. So in 2009, they put in terminology designated brace wall lines. Some people call it imaginary lines, because there is no physical wall on here. There's no physical wall. The physical wall is right here. But as long as from your designated wall line or your imaginary wall line, the one that you designate is your wall line, is that as long as you have a physical wall within 4 feet here on either side of that line, then you can say that that is a designated wall line. So you're a maximum 4-foot offset from the designated wall line, like that first bullet says, and then you're 8 feet from out to out maximum. So you get to this one here, same thing. You can say, okay, I've got a 4-foot here and an 8-foot there. Yeah, I can actually take my wall line and go through here, and from here, I'm less than 4 feet or less, and 4 feet or less that way, with a total of 8 feet out to out. Kind of same thing when you're going discontinuous for an interior wall. If you're saying that, you know, this, you can do it either way. So this is my wall line, well, as long as this is 4 feet here. My designated wall line could be this one here. It doesn't have to be this one, but we just chose this one as your designated one. So designated, and now it's 4 feet within there. And so that is allowed, depending on the distance between the end of this wall and the end of that wall. We'll go into that as well. Yes.
Can a single wall count as part of 2 separate brace wall lines? If it's got offsets of 8 feet, can this wall be a brace wall line, some here brace wall line?
No.
You have to just choose which one you're gonna allow.
Right. Yeah, because you can't allow one wall to count towards both. It's putting too much onto that one wall. If it's loaded, it's trying to go to one or the other, or, you know, try to pick out. I don't know engineering terms on that, but it can only be designated, or it can only count towards one wall.
Is there a formula or something to identify which wall would be the best one to combine with, or kind of just discretion?
Discretion and really the house plans. And it may be that it takes you running it through the calculator to actually determine that. I've never really seen any issues of where I would need to pick to go to one or the other and have any issues, because it's one that if it's that close, if you've got one here and you're wanting to count it to here or to here, it's close enough that you won't need another brace wall line that close to that one. So you can just pick it as one, because you won't need to, you probably will, being that close, you will not need to add another one there. So you can just pick it as one or the other and not have to add another brace wall line there, so.
Because it says, the last picture, what does it say? It says to who's doing the design, they can count the other one, the other actually shorter wall, the equation if it is in 4 feet range.
Right.
Over 4 feet range, it is not included. You can add it if you want to as another brace wall one and do the design on that one, but it's going to be overkill or too complicated.
Right, yeah. And the only way that you can really count these is, say this was 6 feet. The only way that you can really count this as a brace wall panel in a braced wall line, and this its own braced wall line, is that it would have to stop at a perpendicular braced wall line. They either have to stop at an exterior wall or a perpendicular braced wall line. We go over that as well. But you can't just stop it in the middle of the room. It has to stop at a perpendicular braced wall line, so that you have to have a line going through here if these were two different walls, two different wall lines. We'll go more into that as well. So all braced wall panels within a braced wall line shall be permitted to be offset from the designated braced wall line. That's exactly what we
Where
were
you see
saying.
this come in the most is at the front door area and then on the patio. And that's where you're gonna be trying to figure out, hey, do I have that 8 feet that I can use for that offset, so I don't have to put another braced wall on?
And we have examples of those in here. So a lot of these will start to make more sense once we actually go through the plans here. So all exterior walls part of a braced wall line, you can go through and figure out, these are my exterior walls. We know these have to be part of a braced wall line. Now we just have to figure out how we're gonna go about doing them. You got a maximum 60-foot spacing on those, and so from here to there is 60 feet, and then from side to side is our 60 feet. So we don't need to come up with any interior wall lines to divide that out. If that was 70 feet from front to back there, then you would have to have another braced wall line there somewhere, which that's the beauty about today's homes, is that there's offsets everywhere. So even if it is an 80-foot long building, you're gonna have offsets in there, you're gonna have other braced wall lines automatically. And then now we're gonna talk about the offsets here, maximum of 4 feet. So from this one here, you designated this as a wall line. Well, it would have to be because this is 8 feet there. So that would have to be its own wall line, or you could say that I'm gonna designate, conveniently, that's 8 feet. So you've got 8 feet offset, I can designate a wall line right down the middle, as long as my physical wall line falls within 4 feet from each side of that imaginary or designated wall line, then you're good to go.
What if we have a 12 offset?
Yeah, if that was 12 feet, then you could, you would end up having to say that, yeah, this is a braced wall line, and, well, that's 20 feet there, so,
Over 4 feet.
well, yeah, well, this here, and Bill, you can weigh in on this one here. I would say if that was a 12-foot offset there, I would say this is all one wall line going across here.
If that's
Even though there's no wall here, as long as if you have a braced wall panel there and a braced wall panel there, and then they're no more than 25 feet apart on center.
Right.
Would you
Yeah,
agree
if
with
that's
that?
8 feet 2 on offset, then you're gonna have 2 braced wall lines,
Yeah.
and that one will continue on through.
Yeah. So if this was 30 feet distance between here and there, you would say this is a braced wall line, this is a braced wall line, and that's a braced wall line, because your braced wall panel spacing can't be more than 25 feet on center. And we go into that a little bit more. Good questions? Okay, your braced wall line lengths. The end of a braced wall line shall be measured from the intersection with the perpendicular exterior wall or the projection thereof. So you've got this wall going here. It doesn't stop right here. It's going to go to the perpendicular wall here. So that's the projection of it. So that'd be the length of either whichever line you're wanting to call that one. So braced wall line 1 and braced wall, or I guess C and A. The length of A stops at B and the length of C stops at B, because it's an intersecting exterior wall, perpendicular exterior wall for the projection thereof. Or the intersection with a perpendicular braced wall line. No, this is the right slide for this one here. So intersection with a perpendicular braced wall line. So if this is a perpendicular braced wall line here that's more than 8 feet, you can say that it stops here, or the maximum resulting length. I don't like this slide here, I need to look at that, so I think really put this one in. What this actually says, don't look at the example there. On our slide here is, so look at, if you pull out the plan here, we show a good scenario of that, and it's going to be at the front. You could say that looking at the front, there's a study and then the covered entry there. If you look at that and start over at the study, and we're going to say that our braced wall line is, I'm just going to give you the answer for later on, but we're going to designate a wall line probably right down the middle of that offset there. It's 6 foot 10 inches, I think. That offset there, we would designate a wall line going from side to side. So we're saying our braced wall line is going side to side here, and starting at the study. So if I bring my braced wall line, designated wall line over to the other side of that study, that's an exterior wall. So I could stop it there, but I'm joining these two walls here, the front of the study and the entry here. So I'm actually going to take that all the way across. I could stop it at this next exterior wall. It's a perpendicular braced wall line. I could stop it there and be okay. Or I can have it go all the way through, picking up interior wall lines if I need to, and have it go all the way to the other side. It just tells you that really what it says is what I referred to earlier when I was saying that you have a wall line here and a wall line here. It has to stop at a perpendicular braced wall line or an exterior. It could be interior or exterior, but it has to stop at a perpendicular braced wall line. It cannot stop just in the middle of a room with no perpendicular braced wall lines in it.
You cannot add any interior wall to the braced wall line unless you apply the requirement to that wall.
Right. Yeah, you can't just say this is a braced wall line. Your interior braced wall lines have to follow the same as your exterior, whether you're going to use continuous sheath on the inside or you're going to use intermittent methods on the inside. It has to follow the same type of requirements that your interior wall lines do.
What about the sheeting?
Pardon?
What about the sheeting?
The sheathing on interior walls, we'll go over all those options, what you have for interior and exterior. So you've got the plans here. Now you might use your book to put under it and get out your highlighters, because what we're going to do now is designate our, mark up our plans for our braced wall lines. And then from there, we go into what the wall bracing requirements are, and how you're going to get to these, get all your bracing on there.
Let's say one thing, and these are just general rules, and if you remember this, it'll help you a lot. Each braced wall line has to have a panel at each end, okay? Each braced wall line has to have a panel 25 feet on center, okay? Minimum bracing for each wall is 4 feet, okay? No braced wall line can be more than 60 feet. If it is, then you're gonna have to put an interior in, okay? So those are just some basics there. If you remember that when you're doing bracing, that'll all let things fall into place on you.
Absolutely. And kind of how I broke it down into the presentation is I went ahead and started, let's do our braced wall lines now, because now we're not concerned about panels right now. How much bracing is required on any wall. All we're worried about right now is just the placement of braced wall lines. The placement, the spacing, the offsets, the angles. Speaking of angles, we can go back to this one here. And it says that walls are permitted to be angled no more than 45 degrees and no longer than 8 feet. That can't be more than 8 feet of an angle, or it has to be its own braced wall line. So if you're coming along here, you've got a 70-degree angle and 10 feet long, that's braced wall line A, that would be braced wall line B, this would be braced wall line C. So you can count it as bracing, as part of a braced wall line, if it's less than 45 or less, and less than 8 feet in length. And if you do that, say this is 7 feet, 45-degree angle, I guess, and 7 feet. So does it make any difference which line you count that towards, whether it be this one, or both? What do you guys think? Think you should be able to count it for both, or just one and you pick, or? So it's an angled wall. You've got your parameters of the length and the angle that it can be. So now what it says is, does the angled wall can only be part of one other line? So you can't count it as part of this wall and that wall. So you just pick whichever one. Maybe based on window openings here, or what's if you have any kind of braced wall panel there, maybe you need to count it in this direction here, because if you counted it as this wall line here, you've got all kinds of bracing for this one, to where this one here, you've got these openings here. This may be not enough to qualify as a braced wall panel, and then if you started it from here, you'd have to have your first braced wall panel within 12.5 feet, and so you kind of have to figure out everything. And this can make a little more sense when we talk about placement of the panels and openings and everything else. So an angle can only count as one wall line or the other, and you guys can pick which one.
You know what? I have a question here, because when you go to the ladder of forces, force comes in two components when it gets to the angle wall.
Right.
And in that case, the picture of angle wall on the vertical, the picture on the horizontal should be counted. To me, let's say the 45 degree, you have almost 50% of the wall on each side. So,
Right, exactly. Yeah.
so this is the way I believe it's supposed to be.
From an engineering standpoint, yes, that makes absolute sense, that it's gonna go
what,
one.
what the code says.
Right.
Well,
Well,
the code doesn't say you can count it as when you go to the side to side, and from the actually front to the back, you count the picture of the length of the wall on each side when you count.
you can count, you can count this as bracing, and you can count it as part of one line or the other. If this is full of windows here, it really doesn't make any difference if you're not able to get any bracing out of it, it really doesn't make any difference which line you count towards, whether you're counting, and we're just talking about length, the length of that wall. Yeah, so in engineering terms, and that's why I was saying about the ICC, comprised of engineers, builders, and building officials, is it's give and take. Engineers may just have a square house with very few windows, very few openings, because that's more engineered, more sound. Builders want what their homeowners want, which is windows, openings, and everything. So it's a give and take. So it's not going to be that, yeah, this makes perfect sense from an engineering standpoint. It's kind of, it is a give and take in the code. And what the code says is that the length of this wall here can only be counted in this direction or this direction. You can't take 50% of it and go there, 50% go here, even though loads are being applied that way. If you're actually loading that with wind, they're going 50-50
direction.
Yeah, so, as I say, and I think maybe from engineering, they said, builders said, yeah, we need that. And engineers said, okay, well, this is the limits, it has to be 8 feet. You can't have a 20-foot section and still count it as one or the other. It has to be its own. So I think that maybe that's where some give and take is done there.
The code allows you as the builder to design it how you want to. You can put it either way. What comes into play a lot of times is that wall has windows and doors in it. Now, there is no bracing in it, so you have to start trying to figure out, where do I need to go with it?
Yeah.
Yeah, I got it. I have another question.
Uh-huh.
So, you said if the offset walls, if they are less than 25 feet, you cannot count them as a raised wall line. Let's say if you have an offset over 8 feet, 10 feet, 12 feet, whatever, the length of the wall has to be 25 or more.
No, your wall can be 6 feet, 8 feet, 10 feet.
Then you can count it as a raised line?
Yes,
Well-
yes. Anything over
4 feet.
anything over 8 feet, well, in this example here, is that at the front here, you've got an offset of 6 feet 11. So this wall here, in the front and back direction, is going to allow these two walls to be combined here. So this one here is less than 8 feet. It doesn't, every exterior wall has to be part of a braced wall line. So this little offset here is now part of this wall line going here. But you get to the back, that's more than 8 feet
10 feet.
here. So that has to be its own braced wall line. Anything over 8 feet in offset in that perpendicular direction there, anything over 8 feet has to be its own braced wall line because it's not counted here or here.
Is the 25 feet refer to the distance between dividing two walls,
Two
or is
braces.
that opening like this? If you have two walls in the same line, but they're 25 feet apart, 27 feet apart, coming in, those two can't be counted without something connecting them this way. So if it was here, 25 feet space, and then 12 feet this way, you have a line here, a line here, and a line back here. Is that right?
Yes, I think I'm following what you're saying is, so in that example there where, for a house that has a great room, you've got one wall at the front, front bedroom, there's a wall. And then you come to the entry, and the entry is 20 foot tall, all open space. Where your plate height can't be more than 12 feet. So there's ways to design for great rooms is that, yes, you can have your great room there, but as long as the wall that was at the front bedroom there, that plate height is no more than 12 feet tall, and you have then you have your open spot where the great room is, 20-foot walls, as long as that great room is really no more than 21 feet wide, then you can count the other wall that's on the other side, if it falls in line within your 8 feet offsets. On the other side of that great room, you can make that side of it and the side where the bedroom was, you can make that all one wall line and almost disregard the great room area there. And it still has to be framed like code calls out. But for braced wall panels, you don't necessarily need braced wall panels in there if it's only 21 feet wide. If it's more than 21 feet wide, then your braced wall panels that are on either side of it are too far apart. Your braced wall panels can only be no more than 25 feet on center apart. So it's the braced wall panels that you worry about there.
The
It's
ones
how
that
far
are in
apart
the
they
same
are.
line.
Right.
Now, would that count as like a portal frame, or you have to do portal frame method with that? Could you do portal frame hold downs and that sort of thing to make that? Would you require that?
But we can go over that here in a little bit when we actually get to the methods.
Okay.
But like I say, right now, we're just worried about the braced wall lines, how to put those. We're not worried about components of the braced wall lines, any methods or anything like that. So let's mark up your plans. We gave you two highlighters. I work usually in the side-to-side direction. And so side-to-side as in the walls are actually going that direction. So here's my side-to-side direction. And whenever you're putting it into a calculator, we've got an online calculator that if you're putting it into there, I say that's the side-to-side direction. Some people say, oh, no, that's fluid. I'm working from side to side, you know. Just the direction of the line, and it doesn't make any difference which way you do it, just be consistent with how you do it so you know. I always say side-to-side direction is the actual direction that that wall is going from side to side. So, I start at the very front of the house, so look at, you won't be able to see numbers here, and I can tell you what numbers are. Go ahead and turn the lights on now, maybe you can see some numbers on your picture there. Okay, so on the paper, you have got, again, I start at the front of the house, so I'm looking at the garage here. I look at that garage, and I'm gonna have a brace wall line going from here to here, and then can I take it all the way down to there? Because why?
You can use the ports open. And the wall, yes.
Yeah. Yeah, so, yeah, exactly. So the 2 foot offset is, let's get some, take some notes. Okay, yeah, so it's less than a 4 foot offset there, so you can designate a wall line. You can put that wall line anywhere you want. You can put it at the very front here. You can put it on this wall line here. You can put it right down the middle, wherever you want to put that wall line. I always put it as far back as I can, so that way it would get it closer to this wall line. Because the closer your lines are, the less bracing you're gonna need. So, no sense in putting it up the front, you can get it 2 feet closer. So, I put my designated wall, or I put my wall line there. And that's the one that I'm designating is my brace wall line. Okay, so the next wall that I go look at is this one here, and I say, okay, so I can take this right here, but can I include both of those
Split the difference.
by splitting the difference because it is less than 8 feet? And so I mark it up one way. There is no one way is the right way to do brace wall lines. Everyone in here can do it and come up with something completely different, and every one of them will be correct. So just the way I'm doing it isn't the only way that you can do it. Because you could stop it. I'm going to put my designated wall line all the way across here. So mine's going all the way out to out. I'm going to pick up some interior wall here, or this back wall of that, the garage. You probably could, I didn't run numbers, but you probably could stop it right here, because it can stop here, because that's a perpendicular brace wall line here. So you can stop it there. It's an exterior wall, it's a perpendicular brace wall line, so you can stop it there. The only thing is that you may end up, you put it in the calculator, it may say, you need 10 feet of bracing on this wall line here, just this section there. You may not have 10 feet of bracing there. So I use a different bracing method instead of continuous sheath. I use jib board because I've got all this area right here, and this is probably going to be enough bracing for the whole wall line. So I picked that, just out of convenience. Not to say that that's the only way. Okay, so the next braced wall line would have been this one, but it's included in this right here. So the next one, and again, we're just working exterior walls. Exterior walls have to be part of the braced wall line, so you don't have to worry about interior. Unless you've gone through 100 plans and you know what to look for. But as just starting out, you look at the next wall line is this one here. So can I count this one and this one as a braced wall line?
Yes.
Because it's less than 8 feet. Can I count all 3 of these?
No.
Because it's more than 8 feet, so very good. So yeah, you can pick right down the middle. You can pick it to where, I got it as close to this one as I could, but as long as it wasn't any more than 4 feet from that back one there. So I came 4 feet in and it gives me 2 feet or whatever it was. So that's the way I chose that, because there's a lot of glass here, so I'm wanting my braced wall lines to be as close together as I can. That way it lessens the amount of bracing required. Okay, so the next one is going to be this back one here. That's all on its own there. No offsets to worry about there. So that's the direction that I go in. And I don't know what makes it easy for Bill or not. I always mark my lines up, you know, brace wall line. This very first one, I put BWL for brace wall line, BWL 1-1, BWL 2-1, 3-1, and 4-1. That's just how I do it. You don't have to, but it's, like I said, it just, I know that once I put it into the calculator and I print out the calculator, it's gonna have BWL 1-1. And so I can denote that is the right one. So that's why I put those on there. Okay, so that's all the exterior walls and brace wall lines in the side-to-side direction. So now you're gonna work in the front-to-back direction. I always start off with the left-hand side. Start off wherever you want, left or right. Just keep it consistent. Makes it easier for you. So I always start off to the left. Just like I'm reading the book. So the left side is that one there. There's no offsets to worry about there. So front and back direction is usually the easiest one. I tackle the side to side direction first. It's more difficult. So your next one is, your next exterior wall is actually this one right here. But up to interpretation of, we've got people within Simpson that our engineer says, no, that is a brace wall line. This one right here, you have to count that as a brace wall line, even though it's in this wall line here. He says that you have to count it as a brace wall, its own brace wall line, because it's in the perpendicular direction, and none of this bracing that's here actually counts as bracing in this direction, which we'll go over. So that's what he said. You know, Bill sees it the way I do, and a lot of others do, is that we say is that this is included in here. It doesn't have to be its own braced wall line. I can see it from an engineering standpoint because it's getting loaded. And if none of this bracing here actually counts in this direction, you know, it's got to count. You know, it's just connecting those two, but you know, I can see it both ways. It's just that's an interpretation.
It's not gonna work this way, side to side.
Exactly. Yeah, there's nothing there that's, yeah, so. But, you know, they say it doesn't need to count. It doesn't count as bracing in this direction, so it doesn't actually need to be braced. It doesn't have to count in that front to back direction because, you know, by code, it's saying that this here, as long as it's less than 8 feet, it can be counted in this direction here. So it's accounted for. You know, I see it from an engineering standpoint as well, to where you better brace that, you know. But that puts you at a cost disadvantage here in a little bit. I can show you on the next line. So if we're saying that this one does not have to be its own brace wall line because it's in this direction here, the very next one is going to be this one here, the back. So mark that one, and the length of that one, why we stopped it here, is because that's at a it stopped at a perpendicular brace wall there, or a brace wall line.
What if I count that one and put the brace wall line, since they're 4 feet, less than 4 feet apart, 8 feet apart, I just put in the middle of these two walls, the brace wall line for the back and forth, front. Front to the back, the second brace wall line, instead of putting there, I would love to put the brace wall line between that wall and come to the front, side.
Yeah,
This wall, you know?
yeah, you can do that. That's one of my examples. I have that. I've marked it up to where I've made this wall line. It can go all the way through. I mean, you might as well. You can bring it all the way up here, all the way to the front, because this is less than 8 feet. If you put a line right through here, or I don't know that dimension there, but as long as this and this is less than 8 feet, you can put your wall line right down the middle there, and you're using chipboard as your method, and it's going to require 20 feet of bracing or whatever it is. But you can also say, well, this is fully sheathed, that's 6 feet, that's 8 feet or whatever it is, 9 feet.
14.
So you're going to have plenty of bracing there, plus all the chipboard inside. So again, there is no wrong way or right way. It actually is braced, but this wall here actually is braced. In reality, on plan, or in the field, it is braced, but you don't have to necessarily mark it that way on your plans. Again, it's There's no one way is the right way.
You can do it that way if you want,
Absolutely.
that's extra. That would be something that you wanna say, no, I wanna do more than what the code requires,
Right.
In
okay?
that case, that wall, let's say the front wall, if the front wall is 6 feet and the back wall is 9 feet or so, can I count the second brace wall line front to the back? Summation of these two walls, like 15 feet? I should, because they are less than 60 feet apart. They are in one line, and both of them are exterior walls, and they have the requirements of the brace wall lines. So in that case, instead of having 9 foot or 10 feet wall back there, actually I have another piece up front here, and both of these two walls, either I add to my calculation or don't, they are working.
They are
working together.
Right.
So in that case, I would say the second brace wall line would be someplace between these two or one of the others, with the total of both walls, which is instead of 9 feet or 7 feet, I'm gonna have around 15, 16 feet.
And that would be best practice, but not required.
And you could say this is brace wall line A1, B1, C1, if you wanted to break them into
Yes.
3 different ones. You know, you didn't want to pick up say you didn't have this wall in the middle here, you know, this is all open like we do over here, and I'll show you. You know, you may have to say this is brace wall line B and C. You may have to do that.
I can't.
Well, I guess you don't have to because this one is in that direction, but as a best practice, if that's what you want to do, you may have to do it that way. So the next one in that direction here, front to back, is the side of that wall there, and it doesn't have to go inside, doesn't have to pick up anything else. So, again, back to the argument of interpretation is, you know, one of our engineers says that's its own brace wall line right there. So you have to mark that one up. An issue you have with this one being its own brace wall line goes back to what you were asking earlier about spans, how far apart they can be. So if this is its own brace wall line here, it seemed like this was, if I brought it all the way to here, that this was, I don't remember if this was, what's the distance between there? If I was able to count those. No, I could not. Okay. Yeah, we could. You could possibly, if bracing allows, you could say that this is my designated wall line going all the way through and coming out the bare back wall there. But the only problem is, you don't have any bracing in here. From here to here is more than, your brace wall panels are too far apart. So you can't, you'd have to put a wall inside here in order to connect this one to that one down here. So on the side of economically, building it most cost effective is that with this section right here, running calculations, you actually may have to put an alternate braced wall panel there or a steel strong wall, you know, that's a few $100s. To where, like Bill interprets, is that this wall line here is part of this one here, so you don't need to count it as a braced wall line. Anything under 8 feet offset, you don't have to call it its own braced wall line. So that leaves you with the very last one here. No offsets to worry about, and it just runs from end to end there. Any questions on that so far? Okay. Turn the lights off. All right, can you guys see all right, or do we need to turn the lights off?
See from.